Hi, hello, welcome to all of you. Today we start new chapter as a part of the reasoning syllabus, that is counting figures. This is a very easy chapter. In counting figures, we see the figures of how many triangles are there in a given figure, how many squares are there, how many rectangles are there, how many circles are there, how many straight lines are there, how many cubes are there in the given figure. They frame the questions like this. In a given figure, first we go for triangles. Number of triangles in the given figure. Number of triangles in the given figure. Then we go for squares. Squares and rectangles. Squares and rectangles. We study separately squares and rectangles. Then we go for circles. Number of circles in the given figure. Then we go for number of lines. These lines can be slant lines, horizontal lines, vertical lines, diagonal lines. Okay, and diagonal lines also we can study in the given figure. How many diagonal lines are there? How many diagonal lines are there? Then we go for cubes. Then we go for cubes. Okay, we go for cubes. Mostly we focus on triangles, squares and rectangles. These three are very easy and we can study quickly. But in triangles and squares, rectangles, we follow some logics. Some confusion figures are there. We'll see one by one. Okay, now see the first figure. How many triangles are there in the given figure? How many triangles are there in the given figure? See, suppose this is one triangle. This is one triangle. This is one triangle. In the given figure, triangle is like this. In the given figure, triangle is like this, right? In the given figure, triangle is like this. How many triangles are there? First, we study how to identify the triangles. This is one triangle, right? This is one triangle. This is another triangle. This is another triangle. Two small triangles, one bigger triangle. Two small triangles, one bigger triangle. Okay, 1, 2. Just give numbering 1, 2. One figure. How many are there? 1, 2. 1, 2. Clubbing of 2. Clubbing of 2. These two. Clubbing of 2. So 2. Total how many triangles are there? Sorry, 1. One triangle is there, right? One triangle is there. So in the given figure, how many triangles are there? Two small triangles, and one bigger triangle. Two small triangles, one bigger triangle. Total 3 triangles are there. Total 3 triangles are there. Okay, you can count 1, 2 small, 1 big. Figure is small, you can count it easily. What about figure is big? Figure is like this. The figure is like this. 1, 2, 3, 4. Do you count? No, you can't count. So for that, one logic is there. Sorry, you can count here, but it will take some time. So for that, to avoid this confusion, there is one logic is there. We'll see what it is. Okay, we'll see what is the logic here. Give numbering in the gaps. Give numbering in the gaps. 1, 2. 2 gaps are there. Two gaps are there. Give numbering in gaps. 1, 2. 2 gaps are there. Add them all. 1 plus 2. 1 plus 2, which is equal to 3. How many triangles are there in the given figure? 1 plus 2, which is equal to 3. Figure is like this. Give numbering in the gaps. Add them all. I repeat. Figure is like this. Basic figure. Give numbering in the gaps. Add them all. Add them all. Okay. Alright. So if number is big, you know this, right? Sum of the first n natural numbers. Sum of the first n natural numbers. Sum of the first n natural numbers. Hope all of you know this part, which is equal to n into n plus 1 by 2. N into n plus 1 by 2. In this figure, what is the value of n? N equal to 2. So 2 into 3 by 2. 2 cancels, remaining is 3. Number is big, you can directly substitute in this formula, you will get the answer directly. No need to again 1 plus 2 plus 3 plus 4 plus 5 plus 6, like no need to do. Just substitute in the formula, you will get the answer. Number of triangles in the given figure is given by this formula. Basic figure is like this. Okay. Now, we'll see the next question. See, give the numbering in the gaps. Basic figure, numbering in the gaps. 1, 2, 3. 1, 2, 3. 1 plus 2 plus 3, which is equal to 6. 1 plus 2 plus 3, which is equal to 6. Number of triangles in the given figure is 6. Basic figure, number of triangles in the given figure is 6. Next one, same like previous one, a little bigger. So give numbering in the gaps. 1, 2, 3, 4. Give numbering in the gaps. 1, 2, 3, 4. Add them all. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. Which is equal to 10. Or else can go with formula. I told you formula. Sum of the first n natural numbers. N into n plus 1 by 2. N equal to 4. N equal to 4. N plus 1. 4 plus 1, 5 by 2. 4 into 5, 20. 20 by 2, which is equal to 10. 20 by 10, which is equal to 10. Okay. Like this also you can do the question. Now, before this, I'll take other figure. How many triangles are there in the given figure? How many triangles are there in this figure? So try to find out the triangles in the given figure by using this formula. Gaps are there. Try to numbering, give the gap numbering in the gaps. 1, 2, 3, 4, 5, 6. Number of gaps are 6. So number of triangles are 6 into 7 by 2. 6 into 7 by 2. 2 3 is 6, 3 7 is 21. In this figure, how many triangles are there? 21 triangles are there. In this figure, how many triangles are there? 21 triangles are there. Hope this is a basic one. This part is clear to everyone. Now, next model. Little extension to the previous one. Little extension to the previous one. Suppose if figure is like this. If figure is like this. This is the triangle. This is one. This is triangle. Okay. This is the given figure. How many triangles are there in the given figure? How many triangles are there in this given figure? See, this part separate. Count for triangles for this part separate and bigger part separately. For this part separate, for this part separate. This part is like this. Bigger one like this. Smaller one like this. Smaller one like this. Okay. For this part separately and bigger one separately. Upper part separately. Count it separately. Total part separately. Okay. So same like previous one. Give the numbering in the gaps. Numbering in the gaps. 1, 2. Total 3. 1, 2. Total 3. Okay. 1, 2. Total 3. Same like for bigger part. 1, 2. Total 3. 1, 2. Total 3. Add them all. Upper part 3 triangles. Total part 3 triangles. 3 plus 3. Total 6 triangles. Total 6 triangles are there in the given figure. What I am trying to say is, take it as a baseline. Take it as this one as a baseline. If two are there, if another baseline is there, take it as another baseline. This is another baseline. Okay, this is another baseline. Total upper part 3 triangles, lower total part 3 triangles. Total 6 triangles are there. Suppose if figure is like this. If figure is like this. If figure is like this. How many triangles are there in this given figure? How many triangles are there in this given figure? So till this part separately. Till this base part separately. Till this part base part separately. Baseline, second baseline, third baseline. First, second, third 3 baselines. Okay. So give numbering in the gaps. 1 plus 1, 2. 2 gaps are there. Total triangles are how many? 3. For this part, again for this part. For this part, 1, 2. Total 3. Again this part, bigger part. Bigger part. Okay. Bigger part. 1, 2. Total 3. Total 3. Right. So till this part 3. Till this part 3. Total 3. Total for bigger one 3. Total 9 triangles are there. Total 9 triangles are there. Okay. This is the basic idea how to calculate the given number of triangles for the given figure. Or else you can do directly. First calculate base one. If a figure is like this, what do you do? Just do calculate for anything. Calculate number of triangles for this part. Suppose figure is like this, right? Figure is like this. Figure is like this. So how to calculate number of triangles directly? Just give numbering in the gaps. 1, 2, total 3. 1, 2, total 3, right? So then multiply with 3 is there, right? Multiply this 3 with number of baselines. 1 baseline, second baseline, third baseline. First baseline, second baseline, third baseline. First find out number of triangles for the any part, for total part or bigger part or middle part separately. Okay. Then multiply with number of baselines. Number of baselines are how many? This is 1 baseline. This is second baseline. This is third baseline. 3 into 3, total 9. 3 into 3, total 9. Okay. 3 into 3, total 9. Either you can do like this or you can do like this. Once you are clear, this is better method. Okay. First find out number of triangles for the one part, then multiply with the baselines. Now, see the figure. Next question. Gaps are there. 1, 2, 3, 4. 1, 2, 3, 4. Total triangles are 10. Total triangles are 10. Two baselines. One baseline, two baselines. 10 into 2, which is equal to 20. 10 into 2, which is equal to 20. Or this part 10, this part 10. Total 20. Okay. This part 10, this part 10. Total 20. Okay. Hope this part is clear. Now, see next figure. For calculate any one thing. Give numbering in the gaps. 1, 2, 3, 4, 5. 1, 2, 3, 4. Triangles are how many? 5 into 6 by 2, which is equal to 15. Which is equal to 15. Number of triangles are how many? 15. How many baselines are there? One baseline, second baseline, third baseline, four baselines. 4 baselines. 15 into 4, which is equal to 16 triangles. 16 triangles. Okay. 60 triangles, not 16. 60 triangles. Calculate one for one baseline, then multiply with the number of baselines. Okay. You can do here also, but just have idea. You can calculate with the help of this baselines also. Now, see this one. Same like previous one. Give numbering in the gaps. 1, 2, 3, 4, 5, 6. Sum. What is the sum of these numbers? 6 into 7 by 2. 21. 21. 21. How many baselines are there? 21. 21 total triangles. One baseline is 1. Second baseline. Third baseline. 4 baselines. 21 into 4, which is equal to 84. 21 into 4, which is equal to 84. Now, see how many triangles are there in this figure. Give numbering in the gaps, multiply the number of baselines. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Same like previous one, I think. Okay. Total 21. Total 21. Number of baselines are how many? 1, 2, 3, 4, 5. 21 into 5, which is equal to 105. Previously it is 4 baselines. Now it is 5 baselines. Now it is 5 baselines. Okay. Hope this part is clear to everyone. Now, next model. Next model. Suppose triangle is like this. Suppose triangle is like this. Suppose triangle is like this. How to count the number of triangles for this given figure? Okay. So baseline is not complete. Baseline is not complete. Previously it is fully. Now it is some part is there. It's not, baseline is not touching all the lines in the given triangle. For that, how to count the triangles separately? How to count the number of triangles for separately? See, count triangles for this part separately. Count triangle for this part separately. When line is there, when baseline is there, count triangles for that part separately. Then for remaining parts, remaining part. Okay, for bigger part. This is small one. This is bigger one. Okay. Now, see how many triangles are there for this part? 1, 2. Total 3 triangles. Total 3 triangles. Now coming to bigger part. 1, 2, 3. Total 3. Total 6, right? Total 3. For smaller part, 3 triangles. For bigger part, 6 triangles. Total how many? 9 triangles are there. 9 triangles are there. I repeat, baseline is not touching all the lines in the given figure. At that time, what we do? Count separate triangles for this part separately. Then for bigger part separately. If extra lines are there, for that part separately also. We'll see one by one. Just have basic idea first. If line is till this part is there, count number of triangles for this part separately. Then bigger part separately. Then add them all. Okay. I'll take another figure. It will be clear to all of you. Suppose figure is like this. Figure is like this. How many triangles are there in this figure? How many triangles are there in this figure? Baseline for this part separately. One baseline is there for this part separately. 1, 2. Total how many? 3. Now, here one baseline is there. So, count for this part separately. Count for this part separately. How many are there? 1, 2. Total 3. Total 3. Then coming to bigger part. 1, 2, 3. Total 6. For this part, 3 triangles. For this part, 3 triangles. For bigger part, total part, 6 triangles. Total how many? 6 into 3 into 3, which is equal to 12 triangles. Which is equal to 12 triangles. Okay? Which is equal to 12 triangles. Hope this part is clear to everyone. Now we'll see problems. Examination questions. Now, here one baseline, here one baseline, another baseline. Okay? Till for this part, how many triangles? 1, 2, 3. Total 6 triangles. For this part, 1, 2. Total how many triangles? 3 triangles. For this part, 1, 2, 3, 4. This part, how many triangles? 10 triangles. I repeat, for this baseline, 6 triangles. For this baseline, this is the 3 triangles. For bigger part, 1, 2, 3, 4. Total 10 triangles. Total how many triangles? 10 plus 6 plus 3. 10 plus 6 plus 3, which is equal to 19 triangles. 19 triangles. Okay? For this part is clear to everyone. Now, coming to this part. Now, this is the one baseline, another baseline, this baseline, and this baseline. First part, second part, third part, fourth part. Okay? For first part, this is the first part. For this part, how many triangles are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many triangles are there? 15 triangles are there. For that part, how many triangles are there? 15 triangles are there. Now, coming to this part. Okay? Coming to this part. How many triangles are there? 1, 2. Total 3. 1, 2. Total 3. Now, for this part separately. 1, 2. Total 3. For this part separately, we have to count. For that, 3 triangles are there. Now, coming to the total figure. How many gaps? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Same like previous one. Just it is 15. This part, 15, right? 15. Total triangles are how many? 15 plus 3 plus 3. 15 plus 3 plus 3. 30, 33, 36. Total triangles are how many? 36 triangles. Total triangles are how many? 36 triangles. Now, see this part, see this question. One baseline, second baseline, third baseline, fourth baseline, fifth baseline. 5 baselines are there. Count separate triangles for each baseline. For this part, how many triangles? 1, 2. Total 3. For this part, how many? Total 3. For this part, 1, 2, 3, 4. Add them all. 4 into 5 by 10. 4 into 5 by 2, which is equal to 10. For this part, 10 triangles. For this part, 1, 2, 3. How many triangles? 6 triangles. For this part, 1, 2, 3, 4, 5. Total 15 triangles. For this baseline, 3 triangles. For this baseline, 3 triangles. For this baseline, 10 triangles. For this baseline, 6 triangles. Total baseline, 15 triangles. Add them all. 3 plus 6, 9. 9 plus 3, 12. 12 plus 10, 22. 22 plus 15, 37. Number of triangles are there in the given figure is 37. Okay? Add them all. 3 plus 6 plus 3 plus 10 plus 15. 15, which is equal to 37 triangles. 37 triangles. Okay? Hope this part is clear to everyone. Now, take as full line. Okay? Now, see, for one baseline, second baseline, third baseline, fourth baseline, fifth baseline. Okay? Fifth baseline. So, for this part, 1, 2, total 3. For this part, 1, 2, total 3. For this part, 1, 2, 3, 4. Total 10 triangles. 4 into 5 by 2, 10, right? So, for this part, 1, 2, 3, 6 triangles. For the total part, 1, 2, 3, 4, 5, which is equal to 15. Okay? Total 15, right? So, how many triangles are there? 3, 6, 3 plus 3, 10. 3 plus 10, 30. Sorry. 3 plus 10, 30. 16, 22, 37. 37 triangles are there in the given figure. Okay? 3 plus 10, 13. 16, 22, plus 15, 37. Okay? 9, 6, 16, 22, 37. 37 triangles are there. Okay, 37 triangles are there. Now, see this figure and see the next figure. See difference between these two figures. This figure and this figure. Okay. Now, so this is the baseline. This is the baseline. Okay. So count the number of figures. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Total how many triangles are there? 15 triangles are there. Upper part, 15 triangles. Lower part, same. Mirror image, right? So for lower part, how many? 15 triangles. For lower part, 15 triangles. Upper part, 1, 2, 3, 4, 5 gaps are there. You can find out the triangles by using logic. 5 into 6 by 2, which is equal to 15. Same. Down part also 15 triangles are there. Total how many? 30 triangles. 30 triangles. Okay. 30 triangles are there. Total how many triangles are there? 30 triangles. Now, see the next figure. In this figure, this is the line is there. There is a straight line is there. In this figure, there is no straight line. In this figure, straight line is there. In this figure, straight line is there. See how it differentiates, how number of triangles vary. We'll see. From now on, you can see hidden triangles. Hidden triangles are combination of triangles. From now on, we'll see combination of triangles. Now, first give numbering. First find out visible one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Number of triangles are 21. For upper part, number of triangles are 21. For upper part, number of triangles are 21. Now, coming to lower part. For lower part also, number of triangles are 21. Same like previous mirror image. Upper part 21, lower part 21. Total 42. Don't stop here. You should be very careful about combination of triangles. Combination or internal triangles. People say internal triangles, combinational triangles, or hidden triangles. Hidden triangles. I name it hidden triangles. Hidden. That means it's a combination of 2 figures, 3 figures. It will be like this. From now on, you should be very careful. Till now, you can say directly without using any. You never have seen any hidden triangles. From now on, you see some hidden triangles. These are the examination questions. They confuse with the given figure. Okay. Try to remember the one thing. If you get the logic, answer it. Otherwise, leave it, because you can't keep on counting triangles or squares, rectangles for the given figure. Strike once logic strikes, it's okay, fine. Answer the question. Logic is not striking in your head. If you do counting, keep on counting, it will be waste of your time. Mostly all examinations are negative marking, so don't try to waste your time on this counting these figures. If you logic strikes, fine, solve it. Otherwise, just leave it, because figures till this part, okay, fine, you can solve it easily. You can solve easy question, tough questions in an easy way, but sometimes questions will confuse. Some questions will confuse you. Maybe some other triangles are there in a given triangle, in the given figure. So be careful while solving this kind of questions. See, from this figure, you will see some hidden triangles. We'll see one by one. Okay. Upper part 15 triangles, lower part 15 triangles. Now, see combination of these two. Combination of upper part, lower part. Combination of upper part, lower part. Combination of upper part, lower part. Okay. Upper part 21, lower part 21. Okay. Upper part 21, lower part 21. Now, this is the line, right? This line makes the difference here. How it did the difference? Combination of upper part, lower part. This is one triangle. This is another triangle. This is another triangle, right? One triangle, second triangle, 3 triangles. Now, similarly, this side, one triangle, another triangle, another triangle. Right side 3 triangles, left side 3 triangles. Combination of figures. Upper part 21, lower part 21. Because of this line, triangles extra will get extra triangles. Okay. One triangle, second triangle, third triangle. Okay. This is the right side part. And one triangle, second triangle, third triangle. Total 6 triangles you'll get. Total 6 hidden. 6 hidden ones. Okay. 6 hidden ones you get. So total how many are there? 21, 21, 42, 42 plus 6, 48 triangles will get. We'll get 48 triangles. Okay. Be clear. I repeatedly telling you, once you logic is clear, then only solve the questions. Otherwise, don't go for counting manually. Don't count manually. Half of the part you did with the logic. Half of the part you go with the by looking at the combination. Still, people are there. Do the problems by counting. Don't do that. I repeatedly telling you, logic only. If logic strikes, solve it. Otherwise, just leave it. Because negative marking is there, and examination, it will take a lot of time to count the number of figures. Because in examination, we had a less time to solve each question. So don't spend time on questions like this. Okay. This question is this. Some figures are there. We'll see why I'm telling all these things.